Hello all, welcome to our next session in highway engineering. I hope you have seen the previous sessions. We are in transportation engineering, in that we are in highway engineering. In the previous courses we have discussed in detail about the theory part of super elevation and extra widening. This session we will be solving some problems in super elevation and extra widening. So welcome to the session. So the question number 12. You see, you can pause the video and then you can solve yourself, and then anyhow you can come back. A highway is provided with a horizontal curve of, see they have given a highway is provided with a horizontal curve of radius 300 meter in certain locality. Calculate the super elevation required to maintain a design speed of 90 km per hour. Okay. Calculate the maximum allowable speed if the super elevation is limited to 0.07 and the safe limit of friction is 0.35. okay. So they have given you two questions. So the first question was here, calculate the super elevation, okay, if they want to maintain the design speed of 90, and also they have asked if the maximum super elevation is limited to 0.07 and 0.05, they are asking you to determine the maximum allowable speed. So okay, let's do the question. You see here, for the mix, first I should tell you something, like in if there is a design speed, I think I have discussed in detail about an Indian condition, traffic condition. So for a mixed traffic flow condition, usually we will take 75% of the design speed. Okay, so wherever V is there in the design of super elevation, okay, whenever you are designing a super elevation, you should take a mixed traffic flow condition for the step 1. okay, so you can see for the mixed traffic flow condition, super elevation should fully counteract the centrifugal force for 75% of the design speed, as I told you. Okay, so the step 1, if you remember in our design principle, I have told you, usually we will take friction as a 0 in our usual equation of E plus F equal to V square by GR. We will take that friction equal to 0 and we will determine the super elevation required without friction, and also we have to assume that we will take only 75% of the design speed. Okay, rather than we to take full design speed, we will take a 75% of the design speed. And also you should remember that this 0.278, I hope you remember from the side distance problems we have solved, usually it is nothing but 5 by 18. okay, 5 by 18 is nothing but, I hope you know, it is a conversion factor for kilometer per hour to meter per second. You can see in the question they have given 90, right, 90 kilometer per hour. So you can see this 90 is converted into 0.278 and 0.75 is for mixed traffic flow condition, and 90 whole square and divided by GR, right, you can see this formula. So V square by GR, you just substitute everything, you are getting 0.1195, which is 11%. Obviously, which is greater than 7%, you cannot provide this super elevation. Okay, so for the what does it mean? The step 1 means for the design speed of 90 km per hour, you need a super elevation of 11%, which is obviously you cannot provide because IRC is suggesting the maximum super elevation is limited to 7%. okay, so that's why the step 2, you can see, since the value is limited to 0.07, so keeping that in mind, we are going to design the friction as we discussed in the design. Okay, so I hope you remember the formula. Friction is equal to, again, V square by, if you have written the notes, you can refer, this will be your step 2. You can put the, here you should not you should use the formula E max. You can see E max is 0.07. okay, use it, you can use it here, and you cannot use this 0.75 here. okay, sorry, as per the design principle, you should use the 75% of mixed traffic flow condition only in the step 1. So if you take 0.278, it's a kilometer per hour to meter per second into 90 divided by 9.81 into R is radius is 300, which you are getting a friction of 0.142. okay, so which is obviously less than 0.15, hence you can provide the super elevation of 0.07 or 7%. so which is the maximum value, and anyhow we got this as an answer. okay, so I hope I made you clear. There are two steps. Step 1, you are assuming there is no friction, you are determining what is the required super elevation, and you are getting around 11%. and then to provide 7% only, and we are asking the help of the friction, and when the friction required for this particular speed is 0.142, which is less than 0.15 suggested by IRC. So hopefully you can provide super elevation of 7%. Okay, and you no need to reduce the speed. Okay, so coming back, since it is only 0.142, you have some allowance, right? Some allowance up to 0.15. So you can see the maximum allowable speed, which is the second question they have asked, and this is the first question. Okay, so maximum allowable speed, I hope you know the formula, square root of 0.22, and if you remember 0.022 came from adding maximum super elevation and the friction into GR. If you substitute everything, you will get your answer. G is 9.81 and radius is 300. If you substitute, you will get something in meter per second. You can do your algebra using calculator, and then if you convert that meter per second into kilometer per hour, you will get 91.5 kilometer per hour. So you can even allow the maximum speed of 91.5 kilometer per hour. This is your answer for your second question. Okay, so these are the design steps involved. I hope in so many different question papers, like as we discussed in RRB, SSC, they can ask you in different ways, but all the questions will come under these 3 steps. If they are asking you design a super elevation, you have to go by this way. Step 1, find the super elevation whether it is less than 7, or go to step 2, find the friction whether it is less than 0.5, or decide your allowable speed. Okay, so this is your first question. Coming to second question, so they have given you a design speed, the ruling design speed on the curve is 100 km per hour, and the absolute minimum design speed is, okay, for the minimum design speed is understood. Ruling design speed is the actual design speed required as per the design, 100. At least minimum you should have a design speed of 80. So they have given these 2 numbers, and the super elevation on the curve and the coefficient of friction is they have given even that 0.15. okay, so the ruling design radius. Okay, so what is the radius required to maintain everything? So they are asking a beautiful question, you can see. So consider there is a horizontal curve, it seems. In the curve, they have to maintain 100 km per hour as a design speed. Okay, and super elevation 0.7% and friction is 0.15. To have all these things, they are asking a very basic question: what should be the radius I should maintain? Okay, and for 80 also they are asking 2 questions. For 100, what should be the radius I should maintain, and also for 80, what should be the minimum radius I should maintain. So coming to your answers, you can see the ruling design radius. Obviously, you know the step 1 I should convert into meter per second because my formula is in meter per second. So convert that 100 5 by 8 into 5 by 18, actually 5 by 18 into 100, which will give you 27.77 meter per second. Put that in your formula. I hope you know the formula. E plus F equal to V square by GR. Bring the radius on one side and bring everything this side. G into E plus F. That's what I have done. And E is given as 0. You can see here. G is 9.81, E is 0.07, and friction is 0.15. And V square, now since I have converted into kilometer per second already, so I am using that directly. 27.77 whole square, which is equal to 357 meter, approximately 360 meter. Okay, because it is in the option, you can see this 360 meter. So now we have 2 possible answers. Okay, so let's do the same thing for our minimum radius. So here for the minimum radius, the design speed given is 80 km per hour. You do the same steps, 22.77 meter per second. Substitute in the same formula. Only the change is 22, and then you will get the radius of 230 meters. So to maintain a design speed of 80 km per hour, you need a radius of 230 meter, and to maintain 100 km per hour, you need a radius of 360 meters. So I think this is option D. Option D is your answer. Okay, so let's go to the next question. So they are asking the design the rate of super elevation on a highway in a plain terrain. So they have given a plain terrain with a design speed of 100 km per hour. Okay, and with the radius of the curve 500 meters. This is what they are asked, and they have given some options. So before going into the problem itself, you know, as per IRC, in a plain terrain, okay, you cannot have 8.8%. If you remember, in hilly terrain we can go up to 10%. Okay, so if they have given a hilly terrain, then you have to design. In plain terrain, this is the keyword here. So 8.8% cannot be answered, 9.2 cannot be answered because nothing goes beyond 7, 15.72 cannot be an answer, but 7 percentage can be an answer. Okay, so without even solving you should know your answer, but anyhow I have showed you yourself. I hope if you remember the design steps, we are going to do the same. If you don't know that, if you don't know this number 7%, it can IRC suggestion you cannot be more than 7%, you may tick your 8.8%. remember that is wrong. So anyhow, if you know the formula just now we have discussed, neglecting the friction equal to 0 and then keeping the mixed traffic flow condition, you should multiply 0.75 to the design speed, 75% of the design speed divided by GR. So if you substitute everything, you will get your answer 0.088, which is 8.8%. But as per IRC in plain terrain, we know 7%. You no need to try friction and all. Okay, anyhow we know nothing can go beyond 7%. Your answer is 7%. So this problem is very quick if you see. Okay, so the next question, they have given a vehicle width of 2.4 meter. So this is standard. If you remember, I told you 2.44 is a standard number of any design vehicle, and they have given a center of gravity height is 0.75 meter. So they have given something like this, and there is a vehicle and the vehicle width is 2.44 meter and the height is 0.75 meter. Okay, is passing over the curve with the centrifugal ratio. Centrifugal ratio is nothing but P by W. Okay, which is nothing but V square by GR. If you remember, P by W is centrifugal force and W is the weight of the vehicle. So they have given this ratio as a 0.4 and coefficient of friction is given as and they have given F equal to 0.1. The vehicle is, they are asking, okay, good question, whether the vehicle is safe in overturning if I overturn, or whether it is not safe in skidding, not safe in overturning, or not safe in both. Okay, I hope you remember the formulas we have discussed during horizontal alignment. So step 1, you have to determine B by 2H ratio. So this is body dimension ratio. B is 2.4 divided by 2 into 0.75 is given, so which is 1.6, and they have given friction 0.1. We know if B by 2H is greater than V square by GR or that P by W, both are same. Okay, then the vehicle won't vehicle won't overturn. Here we are getting this number as 1.6 and centrifugal ratio is 0.4. So the vehicle will not overturn. Correct? So vehicle will not overturn, or we can say safe in overturn. Okay, so that's the result of step 2. And also we know if the friction is greater than P by W, our vehicle will not skid. In our case, the friction is given is 0.1 and the P by W ratio is 0.4. So this is wrong. So our vehicle is not safe in skidding. So this is your answer, safe in overturning but not safe in skidding. So your option should be this one, option B. It's not safe in skidding. Okay, so next question. So from now I will solve you 2 problems in extra widening. So they are asking, find the widening necessary for horizontal curve having radius 100 meter wheel base. Okay, so wheel base they have given, and pavement width 7 meter is nothing but 2 lane, and vehicle design speed is 70 km/h. Okay, so I hope you know 7 meter wide road means 2 lanes, and we know the formula NL square by 2R plus V by 9.5 into square root of R. So N is nothing but number of lanes 2, L is length of the base. You can substitute. I hope you know the first formula if you remember, which is nothing but mechanical widening plus psychological widening. We extend because of mechanical reasons and we extend the road because of psychological reasons. Mechanical widening is NL square by 2R. N is number of lanes, so 2 into 6.1 square divided by 2 into radius is given 100. So if you substitute those, and this V you should remember, you should substitute in km/h. I should give a hint, whatever the formulas recommended by IRC as an empirical relation, most of the formulas you should use km/h. Okay, we will see V is in km/h, so 70 divided by 9.5 into square root of 100. You solve this using your calculator, you will get these 2 numbers. So total extra widening is 1.1 meter. Only this is extra widening. So the total widening was the question. So we know total width is given as 7 meter, extra widening is 1.1. So if you add everything, you will get 8.11 meter. Okay, So it's quite simple. So you just do the algebra. So the last question for this session, this is GATE 2010 question. So they have given a design speed for a 2-lane road is 80 km per hour. Okay, they have given 2-lane road and the design speed is 80. When a design vehicle with a wheelbase of 6.6 meter is negotiating a horizontal curve on that road, the off tracking is measured as 0.096 meter. I hope I have discussed with you. If you are running, I hope I have discussed with the running race. Consider your track is this one. When you are having a horizontal curve, if you are going to this track or something like this, give me a second. So when you are, if your track is this one and you are going off the track, something like this. Okay, you should run something like this, but you are going off the track in the curves, taking some lane width in the extra track, then it is called off tracking. And if you see, I have given a term L square by 2R is the geometry. It's not an empirical formula. You can see there is a derivation in any textbooks, even in Kanna and Gesto. This is for based on a geometry. Okay, so if you length of the base, if you know, and the radius, you will know how much off tracking your vehicle will go, because L is the length of the base, right? Is just like the straight line of the vehicle. Okay, so they have L square by 2R is the off tracking. They have given that off tracking value 0.096 meter. And then they are asking the required widening of the carriageway of the 2-lane road on the curve is, so they are asking the extra widening. Okay, so it's very quite simple, because they have given L square by R, so already they have given some clue, and also there is a 2-lane, so they have given some clue about the mechanical widening. Okay, so and also you see something is missing in the problem is R. Correct, they didn't give you radius. If you don't know the radius, you cannot solve, because both psychological widening and mechanical widening involves R. So using the off tracking, you can determine the radius. You see, so they have given mechanical widening L square by R, 2R, as I told you, is nothing but a off tracking. So they have given 0.096. Solve this, because length of the base also they have given us 6.6 meter, right? So solving this algebra, you will get the radius as 226.875 meter. If you substitute everything here, and also you can, so you got the radius. Step 1 over. Step 2, we know they are asking extra widening. We know the formula, mechanical widening plus psychological widening. So if you see the step 3, substitute L square by 2R, we know 0.096, and number of lanes we know 2. So if you substitute everything, and we know kilometer per hour they have given 80, and the radius is 226.8. solve these things, we will get 0.75 meter. Okay, so your answer is option C. Okay, so this completes quite few problems in extra widening, and also some problems in super elevation. We will solve more and more problems in, why I solve very less problems, we will be solving the super elevation also in the topic of transition curves also. One of the step will be finding the super elevation. So we will see more and more problems in super elevation in this chapter 2.5 also. Okay, so see in the next session. Thank you.